pressure of air reduces when it moves fast. Let's see some activities related to this. Suspend two identical plastic balls on a string. Blow air between the balls. What happens? Yes, the balls are pushed closer towards each other. When air is blown between the balls, the air between the balls moves faster. As a result, the pressure of air between the balls decreases. As the pressure of air around the balls is comparatively higher, the balls are pushed closer to each other. Next activity. Place a piece of paper crumpled into a small ball at the mouth of a bottle with a narrow neck. Blow air strongly through one side of the mouth of the bottle. What happens to the paper ball? Yes, paper ball thrown outwards. When the air is blown strongly through one side of the mouth of the bottle, the air moves faster. As a result, the pressure of air at that place decreases. As the pressure of the air inside the bottle is comparatively higher, the paper ball thrown outwards. Next activity. Cut a piece of paper 20 cm long and 3 cm wide. Hold the paper piece close to your lip and blow air. What happens? Yes, the paper piece moves up. When the air above the paper piece is blown, the air at that place moves faster and the air pressure at that place decreases. As the pressure at the bottom of the paper is comparatively higher, this moves up the paper. Next one. Arrange a plastic pipe and a funnel as shown here. Place a small plastic ball in the funnel. Can you push the ball out by blowing air through the plastic pipe? Yes, we can push the ball out by blowing air through it. Then invert the funnel while you keep blowing in air. Does the ball fall down? The ball doesn't fall down. While blowing air inside the plastic pipe, the air pressure inside it decreases due to the fast movement of air. At the bottom of the ball, the atmospheric pressure being greater, this pressure pushes the ball upwards. The next activity we have. Place a lighted candle on a table. Try to blow air onto the flame using a funnel. What happens? Does the flame extinguish? No, the flame doesn't extinguish. The flame moves closer because the pressure there reduces when air moves out fast. In all these activities, it is common that pressure of air reduces when it moves fast. This principle was explained by a scientist called Bernoulli. Hence, it is called Bernoulli's principle. Next, we have studied about liquid pressure. The pressure exerted by a liquid is called liquid pressure. The polythene bag sticks to the hand when it is tied on your hand and immersed it in a bucket of water, and the inflation of balloon which is fixed to a PVC pipe is due to the pressure exerted by water. Liquid exert pressure in all directions. Fill air in a balloon and fix pieces of sellotape at different parts of the balloon. Make a small hole using a needle on the balloon at the portions where the pieces of sellotape are fixed. Repeat the experiment done earlier using this balloon. What happens here? The water gushes out in all directions. This shows liquid can exert pressure all around. Make a few small holes of same size around a plastic bottle. Pour water into the bottle. What's your observation? Yes, water is ejected out all the holes equally. Thus we can say liquids exert pressure in all directions. Another activity. Make 3 holes in equal distance from each other upwards from the bottom of a long plastic bottle. Fill the bottle with water, keeping the holes closed. Observe the flow of water coming out. The speed of water flow decreases as the water level in the bottle decreases. Thus we can say liquid pressure decreases as depth increases and liquid pressure increases as depth increases. Take a vessel full of water. Keep one end of thin plastic tube at the bottom of the vessel. Blow air gently through the other end. Is there any change in the size of bubbles rising from the bottom to the top? Yes, the size of the air bubble increases as rising from the bottom to the top. The liquid pressure at the bottom is more than that at the top. Dams are broader at the base than at the top. This is to withstand the high pressure exerted by water at the depths. If it is not done, the high pressure may cause the dam to break. The last portion in this chapter is pressure gauge. Pressure gauge is a device used to measure liquid pressure. Students, our 7th chapter, Pressure in Liquids and Gases, has completed. In this chapter, you have studied so many activities related to pressure and some of the devices that works on the basis of pressure. Thank you.